students, today we are going to see some more interesting and important questions from Narendraavasthi sir's physical chemistry, redox reaction. Come on, let us discuss few more questions from this session. Okay, now the first question, a mixture containing 0.05 mole of K2CO2O7 and 0.02 mole of KMNO4 was treated with excess of potassium iodide in acidic medium. The liberated iodine required 1 liter of thiosulfide, sodium thiosulfide, okay, thiosolution for titration. Now we have to identify that concentration of sodium thiosulfide solution. Okay, so that options they have given so that easily we can identify. Now here two main things we have to identify. First and foremost, this mixtures they have given no oxidizing agent, that is potassium dichromate and potassium permanganate. We have to identify the N factor right now because that is reacting with what it is, potassium iodide in acidic medium. Then the liberated iodine is required 1 liter of thiosulfide solution. So that now we have to identify what it is, concentration of thiosulfide solution. Okay, now come on, let us check. Already you have seen this question in a different way. Here, this is another one more example, right? Okay, now this is in the acidic medium only they mentioned. So acidic medium, you know very well, acidic medium, potassium dichromates, K2Cr2O7. So K2Cr2O7 here in this point, here Cr2O7 2 minus, so which is converted to Cr3 plus. So here what it is, water molecules, here 7 water molecules, and here what it is, 14 H plus ion, and number of electron change here what it is, oxidation state, it is +7 oxidation, which is converted to +3 oxidation. So number of electron change here what it is, 6 electron change. How come it is 6? Here 2, Cr2 is there, no? So per atom of chromium, right, 3 electron. Therefore here 2 atoms of chromium. So here 6 electrons. So N factor it is 6. Okay. So N factor of chromium, that is 6 electrons. Number of electron change. Okay. Now potassium permanganate, KMNO4. So you know very well what it is, MnO4 minus, which is converted to Mn2 plus. Plus here 4 water molecules, no, 4 H2O, and here what it is, 8 H plus ion. Now how many number of electron change here, +7, which is converted to +2. So that means number of electron change here what it is, 5 electron change. So 5 electron change means here 5 electron change. So what you will write it here, N factor of KMNO4, that is what it is, 5 electron change. Right, now the second point what we have to find out here, a total equivalence we have to identify. So total equivalence, that is equal to the mixture of potassium dichromate and potassium permanganate, we have to add with the N factor. Okay, come on, let us find out. So total equivalence. So total equivalence is equal to what it is here, moles of K2Cr2O7 into what it is, N factor plus moles of KMNO4 into N factor, right? So these both, let us apply the value. So here what it is, they have given the data now. So this is 0.05 into 6 potassium dichromate 6, that is N factor, plus, right, plus 0.02 into 5. So both combined together you will be getting what it is here, 0.30 plus 0.10. So you will be getting what it is, 0.40. Okay, so equivalence. Right, got it? Okay, now the next one here, what you will find out, you have to find out that concentration, that is the main point, right? So concentration of Na2S2O3 we have to identify. For that we have to find out the normality of what it is, thiosolution we have to identify. So generally normality equal to equivalence by volume of solution in liter. Equivalence divided by volume in liter, volume of solution in liter. Okay, so here what it is, equivalence 0.40, equivalence divided by volume of solution in liter, 1 liter they mentioned, no? Okay, so that means what it is, 0.40 N. So we found that normality, so it will be easy to identify the molarity, right? Okay, so here in this point, normality of thiose solution Na2S2O3 is 0.40 N. Right. Now, next one, what it is? Titration against iodide. That is, I just mentioned in the question. Here, titration I minus with Na2S2O3. Okay. So, here what it is? Titration against what it is? I minus with Na2S2O3. Okay, now this one we have to check that reaction. Okay, now here what it is? I2 plus S2O3 2 minus. It gives what it is? 2I minus plus S4O6 2 minus. Right. Okay, now here n factor of okay, n factor of Na2S2O3. So how much here? It is 1 electron only. Why you know? Because it lost 1 electron only per S2O3 compound, right? So here it is due to 1 electron lost per S2O3 2 minus. That is what? 1 electron. Right. Now here molarity, first and foremost I would like to mention here normality. Normality equal to molarity into n factor. This you know very well. So this is n factor. Right. Now here molarity we have to bring it out. Okay, molarity. So molarity equal to normality divided by n factor. Right. So normality already we found how much it is. 0.40, isn't it? N divided by n factor, it is 1 per atom Na2S2O3. Here per S2O3 2 minus, it is 1. So you will get what it is? 0.40 m. This is molarity, no, concentration m, that is mole per liter. Right. So which is the correct option? So this is the answer option. Let us check. I hope you got the clarity. How do we go for it? Here mixture of n factor we have found it. Then after the titration against iodine with the Na2S2O3. So this one, how do we identify? That is from the normality. Then we can go and number of electrons exchange, that is n factor. Then we finally we can get the idea about to find the what it is molarity of thiosulfide solution. I hope you got that idea. And see, there are many questions like this. Concept it is same, right? You got the idea. Now which is the correct option? Option A is the correct option, right? So A is the correct option. Mole per liter, mole inverse. So 0.40 is the answer. Come on, let's go to the next question. The next question, 25 ml of 2N HCl, 50 ml of 4N HNO3 and X ml of 2M H2SO4 are mixed together and the total volume is made up to 1 liter dilution, right? 50 ml of this acid mixture completely reacted with 25 ml of 1N Na2CO3, that is basic solution, right? Salt solution, right? Now the value of X we have to identify. So value of X, where it is? See, value of X. So here they have given 25 ml of 2N HCl, 50 ml of 4N HNO3 and X ml of 2M H2SO4. Just you observe, here they have given normality, here they have given normality, here they have given molarity. So we have to find out the normality. In that way we have to identify the X ml, that is how much ml we require for this. And finally we can identify this. After dilution, this is this mixture is mixed together and the total volume is made up to 1 liter, right? So here 25 ml and here 50 ml. So that means remaining. Let us check with that. Okay, so total volume is made up to 1 liter. After dilution, 50 ml of this acid mixture is completely reacted with 25 ml of 1N sodium carbonate solution. So the value of X. See, really it is very interesting and important question also. Same kind of question you can expect, right? Come on, let us check the data clearly because there are so many mixtures they have given. No? So let us write each and everything. HCl, HNO3 and H2SO4. So here volume and normality we can write it. Volume how much here? HCl it is 25 ml and here what it is 50 ml and this is XML, right? This is XML. Now normality what it is? Normality it is here 2N normality, here 4N normality, here 2M molarity. Please note down. Okay, now here generally normality equal to, so these are the data. Let us check point by point. Okay, so normality generally how do we observe? Molarity into N factor, right? Molarity into N factor. Okay, so molarity into N factor means here is the answer. Actually H2SO4, what is it? N factor, it is 2. And normality, here molarity into N factor, molarity they have given here. And N factor basically in H2SO4 it is 2, right? So normality equal to normality normality of H2SO4 equal to, here molarity 2m into n factor, it is 2, H2SO4, H2SO4. So it is 2. So you will get what it is, normality n, right? So 4n. Right, you got this point also here. So you will get that normality 4n. Right, you got it. Right. Now we have to identify that acid mixture dilution up to 1 liter, right? So acid mixture dilution. So everything I'll write it clearly so that it will help you to understand clearly. Okay, so actually acid mixture diluted up to 1 liter, that is 1000 ml, right? 1000 ml. Now here in that 1000 ml, 50 ml of this mixture is completely reacted. So this mixture, actually this diluted acid mixture HNO3, HCl and H2SO4 completely diluted up to 1000 ml, that is 1 liter. So in that 50 ml which is reacted completely, right? So here in this point 50 ml of this mixture, MIXTURE mixture, completely reacted with 25 ml of completely reacted with 25 ml of 1N Na2CO3, that is basic solution. Okay, solution, right? Now so this is base, so acid mixture combined to base, acid base reaction. Okay, now we have to identify that normality of this, and then finally we can come to the concentration, what they are asking in the question. So X value, X ml, that we can identify. So here what it is, normality, again I just bring that normality equal to number of equivalents divided by volume in liter. Okay, volume of solution in liter. Okay, so for that we have to identify that equivalence, right? So actually equivalent of acid mixture equal to equivalence of base. Base is what it is, Na2CO3. Acid mixture HCl, HNO3 and H2SO4. Okay, so these both we can identify. Okay, so equivalence, how do we identify? Here molarity into volume of solution, right? So normality into volume of solution, sorry, normality into volume of solution, equivalent of so and so. How do we identify? Normality into volume of solution, right? So normality into volume of solution, each and everything we can identify. HCl plus HNO3 plus H2SO4. H2SO4 normality also we found just right. Okay, now here for HCl, what it is, here in that 2N it has mentioned, no? So in that here data I have written over here 2N 25 ml, 4N 50 ml and 4N XML, right? You got it now, all those data. Okay, now let us apply that. So 2N into 25 ml plus here what it is, 4N into 50 ml, right? Here 50 ml and plus XML, what it is, here also 4N into XML, right? So this is only equal to, here what it is, the question, I mean that point, we have to identify this point, right? Equivalent of acid mixture is equal to equivalent of base. The same equivalent of acid equal to equivalent of base. How much it is, they have given here, they did not mention about that, but 25 ml they mentioned, no? So 25 ml. So 50 ml of this mixture is completely reacted with 25 ml of 1N Na2CO3. So equivalence of base, it is normality into volume. No, so normality it is 1N. Here I just change this point. So 1N into volume 25 ml. I hope you got that idea. So this is acid mixture and this is a base mixture. Yes, I just indicate this. So this is completely acid mixture. This is completely base. Acid mixture and this is base. So this is equivalent. Equivalent of acid mixture is equal to equivalent of base. Okay, come on. Let us check with that here. Now here, here 50 equivalents plus here what it is, 200, right? 200 equivalent plus here what it is, 4x equivalent equal to how much it is here in this point, 25 equivalents, because this one, right? You got that complete. Now we have to check here. This is completely based on what it is. I have to mention this point. this is completely based on what it is, 1000 ml. In that 50 ml, it has to reacting, right? I wanted to mention that point. So completely, you know, all these, what are the applying point that I have given. Now I'm going to introduce this point. What is that point? Actually, acid mixture is diluted up to 1 liter, that is 1000 ml. In that 50 ml of this mixture is completely reacted with 25 ml of 1. So 50, what it is here in this point, 50 divided by 1000 I have to mention. So here only I wanted to mention. So in this point here, 50 divided by 1000. So here I have to introduce. Anyway, I just mentioned here. So here 50 divided by 1000. Right? Why I am mentioning this point? Here it has to calculate with that. In that 50 ml completely reacted 25 ml of 1N HNO3, right? That is the reason, right? Okay, now let us find out that value. Here this and this will be cancelled. Now here, so 50 to 50 plus 4x equal to 25, right? In this point, 5 divided by 100 is there, no? So let me bring this side, right? So 250 plus 4x, 5 divided by 100 equal to 25. This 25, it is a base. These are all completely acid, right? Acid mixture. Acid mixture only, it has diluted up to 1 liter, right? That is what, right? I hope you got that idea. Yes. Now let us check, let us do with that small rearrangement. So 25, that means 250 plus 4x. You know how do we get the 250? When we add these two, right? So 250 plus 4x equal to 25. These 25 into 100 divided by 5. I hope you got that idea. This cross multiplication in that way. Okay, so when we go for it, so 4x, I just to bring it out. So 4x equal to what it is? 4x equal to 500. Here what it is? 500 minus 250. How do we get that 500? Here 5 ones are 5, 5 5s are 25, no, 5 5s are 25. Okay, so 5 into 100, 500. So that means here 4x, we bring it outside. So 500 minus 250. So you will get what it is? 250. So here we just rearrange all these points now. So we have taken this point also. That is what we just bring it. I told you not to rearrange that. So 4x equal to 250, right? 4x equal to 250. So x equal to 250 divided by 4. So you will get how much? 62.5. So 62.5, this is actually x wrong. So this x, where do we get this x? I just bring that point over here. 4x is there, no? So 4x is x ml. Here everywhere 4n into x ml. ml. So this is x is nothing. X we got the answer, no? This is nothing. ml. So ml, what it is? H2SO4, volume of H2SO4, x ml of 2m H2SO4 we have mentioned, you know, in the question. So that point only. I hope you got that clarity. You know, the question looks so big, but it is easy to understand if you know that idea and how to get that data. If you know the data, arrange it orderly, so it will be easy. How many points if they are giving also, you know that idea, that means a concept, and arrange according to that order of data, so it will be easy. So this is what xml of 2m H2SO4, that xml only 4x, we got it now, that normality, through normality we have found. So through that we have found that equivalence of acid mixture. So finally we are bringing that xml, it is nothing, 62.5. so which is the correct option? Option B is the correct option. Simple, right? Interesting also and easy, right? Come on, let's go to the next question. So option B is the correct option. I hope you got that complete idea about this question. Come on, let's go to the next question. Next question. In an iodometric estimation, the following reaction occurs. See, this is another one iodometric titration, right? Okay, now here copper 2 plus, that means Cu2 plus 4I minus, it gives Cu2I2 plus I2. Now the second equation, I2 plus 2 Na2S2O3, it gives 2 NaI plus Na2S4O6. Now here 0.12 mole of copper sulfate was added to excess of potassium iodide solution, and the liberated iodine required 120 ml of hypo, it is nothing, sodium thiosulfate only. Okay, so the molarity of hypo solution, so the molarity of sodium thiosulfate solution only we have to identify. So for that, let us check the equation thoroughly so we can find the number of moles required. Then finally we can go and identify the molarity of hypo solution. Okay, now here 2 Cu2 plus 4I minus, it gives what it is, Cu2I2 plus I2 here. Okay, now here actually how many moles actually here? This here 2 moles of copper Cu2 plus is there. To produce how many iodine is available? 1 mole. So 2, that means 2 moles of Cu2 plus 2 moles of Cu2 plus produce How many moles of iodine? 1 mole of iodine. Iodine only we are considering. They are mentioning about that only, right? Okay, now the next point, what it is here, titration with tion, the another one. Okay, so I2 plus Na2S2O3, another one equation. I just bring that point. Okay, I2 plus Na2S2O3, it gives what it is, NaI plus Na2S4 S4O6, right? Now here what it is, 2 they mention, and here also 2, right? Balancing equation. Right, now here how many moles required? So balancing also they have provided. So here 1 mole of iodine reacts. Here 1 mole of iodine reacts with 2 moles of hypo, that is sodium thiosulfate, right? 2 moles of what it is, sodium thiosulfate. Sodium thiosulfate, it is nothing, hypo, Na2S2O3, hypo. Okay, now here moles of I2 produced. Okay, now let us check that moles of I2 produced is equal to moles of CuSO4 divided by moles of what it is, Cu2 plus used, that means consumed, moles of Cu2 plus consumed or used. I just put used only. Why I have given this formula? To apply the value. So moles of CuSO4, how much in the question only they have provided. So moles of CuSO4, it is 0.12 mole of CuSO4, right? So and how many moles it has consumed? 2, right? That is what purposely I have given this formula for you to understand the question. So here can you apply the value here, 0.12 mole divided by number of moles used for this reaction here too in that stoichiometric equation. So here you will get what it is, 0.06 moles. So moles of iodine produced, moles of I2 produced, it is 0.06 moles, right? Now we have to identify another one more point here, what it is, moles of thiosulfate solution, right? So moles of thiosulfate required. Here I'll change this color. So moles of thiosulfate, Na2S2O3. So thiosulfate, we have to mention it is a thiosulfate, and it is also called as hypo, right? Please remember. So this is needed. Moles of thiosulfate needed, that is equal to how much? Here 2. There also it is 2 moles it has mentioned, no? So 2 into moles of iodine, right? So here what it is, 2 into here 2. How do you get the 2? That equation, no? In that equation, 2 moles of thiosulfate, no? So 2 into iodine, just now we got it, no? Produced 2 into 0.06 moles. Iodine only we are mentioning, right? Okay, now here, so what is the answer you are getting? Here you are getting what it is, 0.12 moles. Right, now finally we are coming to the point, what is the question in that? Molarity of thiosulfate. So that only we have to identify. So molarity of thiosulfate, that is also called hypo, right? A hypo only I just mentioned because in the question hypo, it is nothing, Na2S2O3 sodium thiosulfate, right? So here how we can bring that? Moles divided by volume of solution in liter. So volume of solution in liter, so 0.12 moles divided by 0.120 mole. It is in liter, right? Volume of solution in liter, where it is 0.120. Here they have mentioned now ml. So ml we converted into liter because molarity it is number of moles of the solute divided by volume of solution in liters. So this point only I just mentioned this point. Okay, right? I hope you got that idea. Okay, come on. Finally, we are getting that answer. So that is number of moles divided by, this is number of moles of sodium thiosulfate only, right? Required, needed. Okay, so you are getting the answer. Now, what is the answer? You are getting 1.0 molarity. Right, this is molarity, no? M, capital M. So capital M, it is 1 M, right? So molarity of hypo, it is the same thing. Molarity of hypo, that is Na2S2O3 sodium thiosulfate, it is 1 M. Got it? Come on, let us check the answer, which is the correct option. Yeah, option D, 1.0 is the correct option. I hope you got the clarity. And yes, from this only you can identify. See here and all, you don't need to go for given mass, molecular mass. Number of moles required, from there only we can, how much it has produced, how much it has taken, consumed, from there only you can get that idea. Yes, come on, let's go to the next question. 1 gram mixture of equal number of mole of lithium carbonate Li2CO3 and other metal carbonate M2CO3 required 21.6 ml of 0.5 N HCl for complete neutralization reaction. What is the approximate atomic mass of the other metal? See, this is like going around the neck, but it is easy. I'll give that idea how to identify. So they have given that mixture. That means given mass, they have given 1 gram mixture of equal number of mole. Okay, that means here 1 mole means there also 1 mole. So equal number of mole of lithium carbonate and other metal carbonate. So other metal carbonate, they did not mention that. Okay, required volume how much? 21.6 ml and normality 0.5 N normality HCl for complete neutralization acid-base reaction. Okay, so what is the approximate atomic mass of the other metal? So this is metal carbonate. Now, other metal they are asking, right? See, this is like going around the neck only, but it is actually easy to identify. Come on, let us check the idea how to go for it. Okay, now here we have to identify the number of moles of HCl. Okay, so here moles of HCl equal to volume into normality. So volume, how much they have given here? 21.6 ml. We can convert it into what it is, liter. Okay, volume how much? 21.6 divided by 1000. Okay, so it converted into liter, right? Into normality, how much here they mentioned? 0.5 N. Right, so moles, how do we identify? Volume into normality. So how much you are getting here? Moles of HCl, how much you are getting? 0.0108 moles. So moles of HCl, it is this much. 0.0108 moles, right? Okay, now next one, number of moles of carbonate ion. Okay, a number of moles of carbonate ion. They mentioned, carbonate ion. CO3 2 minus. Right, so number of moles of carbonate ion reacts with what it is? 2 moles of HCl. Actually here 2 moles of HCl. How do we get 2 moles of HCl? So this carbonate, equimolar mixture of equal number of mole of lithium carbonate and other metal carbonate required 21.6 ml of 0.5 N HCl completely neutralized with HCl, right? So that means here how much of moles required? Naturally, it is 2 moles required when you write that equation. So 2 moles of HCl it is required. So total moles of carbonate, because it is 2 carbonate ion is available, no, lithium carbonate and metal carbonate another one. So total moles of carbonate ion. So moles of HCl divided by 2. 2 is what it is, HCl, right? So moles of carbonate ion, moles of HCl by 2. So you'll be getting how much? So here 0.108, right? 0.0108. 108 divided by 2. So you'll be getting around 0.0054 mole. Right, so this completely indicates here. So total moles of carbonate, because here both are mixture, no? Okay, now so this is actually 2 moles, not 2. So 2N equal to 0.0054 mole. Why I mentioned 2? Because lithium carbonate also available, other metal carbonate also available. So 2 moles of total moles I just mentioned. So 2 moles of carbonate ion equal to this much. So N equal to, so each one, it is equimolar, right? So equal number of moles. So 0.0054 divided by 2. So you will be getting around what? It is 0.0027 moles of each. I just mentioned each carbonate ion. I hope you got that idea. Okay, now we have to identify the total mass of the mixture. Okay, atomic mass we have to identify. For the total mass of the mixture, 1 gram they have given mass. So total mass of the mixture. What is that mixture? Lithium carbonate and other metal carbonate. So this is 1 gram, right? Okay, so N into molar mass of lithium carbonate. Molar mass of lithium carbonate plus molar mass of metal carbonate, M2CO3. In the question it has mentioned, no? So both combined together, it is actually what it is, equal to 1 gram. That is what now total mass of the mixture, that is carbonate, CO3 2 minus. Right, so 2 minus. So that is completely molar mass of lithium carbonate plus molar mass of metal carbonate into number of moles, right? That is 1 gram. So molar mass of lithium carbonate, yes. Molar mass of lithium carbonate. Lithium carbonate, how much? It is 74 gram per mole. Right, here molar mass of M2CO3. Molar mass of M2CO3, right? M2CO3. So here what it is? here M2 no, so we can make it as a X. So 2X plus carbonate what it is here 12 and here 16 into 3. So you will get what it is 60. Right. So this is gram per mole. Gram per mole. Okay, why I mentioned 2X? Because here M2 no, X we don't know, atomic mass we don't know, that is what 2X, right? So X, it is a atomic mass of the metal, atomic mass of metal, right? Remember this point. Okay, now let us identify that point. So now X equal to what it is 0.0027, what it is carbonate ion, into what it is 74 it is what it is molar mass of lithium carbonate, plus that is number of moles now, plus here 2x plus 60, that is equal to 1, what it is 1 gram. Right now the next point what we are going to mention, so here 74, here 74 plus 60, this point we can bring it, okay, 60 into 2x equal to 1 gram, right? So that means here how much you'll be getting when you add these two, 134 plus 2x equal to 1 by here what it is 0.0027, right? 27 what it is, that is number of moles no. So this one, see this point as well as this point, when we add you're getting this one, and 2x is equal to 1 by 1 gram, this 1 gram divided by this point which is coming down, right? I hope you got that idea. Okay, so now when we calculate this point, you will be getting around 370, right? 370 you are getting now. So that means here 134 plus 2x is equal to 370. Now 2x we just bring it this side. So 2x equal to, I hope you got that idea. How do we bring this point and this one? So this is each mole carbonate ion, that is number of moles of each carbonate ion into lithium carbonate plus a metal, that is 2x M2CO3 now. So this is 2x plus 60, so that is equal to 1. Now this 74 plus 60 into 2x equal to 1 gram. Now we are adding, and then this 0.0027 comes down, and 1 by, right? That rearrangement and all, it's easy only if you know that mathematical ideas, right? Okay, now here 2x equal to what it is, we just bring this side. So 370 minus 134, how do we get it? That addition of lithium carbonates, right? So that point, so you 2x equal to how much you are getting, 236. So 2x equal to 236. So x equal to, x is nothing, what it is, atomic mass of the metal carbonate, right? So metal, so 236 divided by 2, so you will be getting 118. So 118 what it is, AMU, so that is unit, we can write it U also, right? Right, so atomic mass of metal, atomic mass of metal. See how it's so simple, but how they are asking that question, really such kind of questions only you have to practice and you get that idea. Say that 2-3 questions if you go through, no, so it will be easy to identify. You will get that idea, right? The same values they will not provide, but you will get that idea from that. So now which is the correct option? So D is the correct option. I hope you got the clarity. Now you know how to identify. Just go through once again so that you will come to know that clear idea. And come on, let us go to the next question. The next question, 32 gram of a sample of FeSO4 7H2O were dissolved in dilute sulfuric acid and water, and its volume was made up to 1 liter. 25 ml of this solution required 20 ml of 0.02 m KMnO4 solution for complete oxidation. Now calculate the mass percentage of FeSO4 7H2O in the sample. So this is like what it is, mass percentage, purity of the sample, mass percentage we have to identify. And next one, what it is, N factor of that, what it is, FeSO4 and KMnO4, that you know very well. It is famous half reaction. So you know, come on, let us check with that. So here I just mentioned, so before I could write that half reaction, I think by this time you might have completed. So first thing what it is, KMnO4, right? So here KMnO4 and FeSO4, right? So KMnO4 and FeSO4 7H2O. So half reaction what it is, MnO4 minus, it is converted to Mn2 plus. So here what it is, 4H2O, and here 8H plus ion. Number of electron change, here 5 electron change. How do you get that 5 electron? Because oxidation number here 7, here plus 2. So when you convert this, number of electron change, here 5 electron change. So N factor, what it is, 5 electron, right? And the same way Fe2 plus. So here Fe2 plus, which is converted to Fe3 plus, right? Okay, now N factor, that is 1 electron. So here 1 mole of KMnO4 reacts 5 moles of what it is, 5 moles of Fe2 plus, right? So I just mentioned in words so that it will be easy to understand. So 1 mole of KMnO4, 1 mole of KMnO4 reacts with 5 moles of FeSO4, right? So ratio, molar ratio, okay, ratio of the moles equal to 1:5. Now here KMnO4, let us check with it. Okay, number of moles of KMnO4 equal to molarity into volume of solution in liter, So molarity, what it is, 0.02 in the question it has mentioned, right? And volume of solution 0.020, that is liter, right? So what is the answer you will be getting? 4 into 10 to the power of minus 4 moles, right? So what is the answer? Whose is that? So number of moles of KMnO4. So number of moles of KMnO4, how much you are getting? 4 into 10 to the power of minus 4 mole, right? Now next to 1 moles of FeSO4 we have to identify. So moles of FeSO4, yeah, okay. So here moles of FeSO4. So moles of FeSO4, that is 5. So 5 moles required, no? So 5 into moles of KMnO4, right? So 5 into moles of KMnO4, this is that moles of KMnO4, no? So let us apply that. 5 into 4 into 10 to the power of minus 4. Okay, 0.00, like that also we can say. Directly we can go for that point. 4 into 10 to the power of minus 4 mole, right? So you will get how much? 20 into 10 to the power of minus 4 mole. We can write this way also. 2 into 10 to the power of minus 3 mole, right? See this point. Right, now next to one. Now total moles and mass of FeSO4 we have to identify. So total moles. So the total moles and mass. Total moles and mass of FeSO4 dot 7H2O, right? So total moles, how much they mention here? 2 into 10 to the power of 2 into 10 to the power of what it is? Minus 3 mole. Okay, so total moles into volume of solution, no? So total moles equal to moles into volume of solution in liter, right? So here total moles 2 into 10 to the power of minus 3 mole into volume of solution, how much? Here 1 liter they mentioned, no? So it has mentioned 1 liter. Yeah, I just bring that point for you. See here 20 ml, 1 liter. The volume was made up to 1 liter. So that is what volume of solution in liter, right? So 1 liter means here we can bring it in that way. Here 1000 divided by 25 ml. In the question data it has mentioned, right? Okay, so you will be getting the answer here. Total moles of FeSO4 only I'm mentioning because KMnO4 over. So this is only I'm bringing. Okay, so here what it is, how much you'll be getting? 0.08 mole. I hope you are following all these points. I hope you will understand also. Yeah, come on. Now molar mass of FeSO4 you have to identify. So total moles of FeSO4, this, right? Molar mass of FeSO4 dot 7H2O. So here what it is, 56 plus 32 plus 16 into 4 plus 7 into 18, right? So altogether you will be getting around what it is, 278 gram per mole, right? That is molar mass of FeSO4, right? Now mass of pure sample, mass of pure sample, mass of pure sample equal to moles into molar mass. So same idea, even previous question, 2 questions before also we have gone through the same idea only. So molar mass, first question also related such kind of question only. Okay, come on. Now what is the answer? That is actually mass of pure sample. It is a given mass. That is what given mass. That is what it is. Number of moles if you are finding means given mass by molecular mass we are finding, no, the same given mass of pure sample, moles into molar mass. So you will get the given mass. So let us apply the value here. How do we get the term? This point here, moles into molar mass. So here moles into molar mass, that is 0.08 moles. Sample, how much they have given that sample moles. This is okay. Into molar mass, how much it is? 278 gram per mole. This is mole. right? So this is given mass. Moles and moles will be cancelled. So you'll be getting gram. So how much it is? 22.24 gram. That is given mass. Given mass of what it is? FeSO4 7H2O. I hope you are receiving the correct idea how we are solving. Yes. Now we are going to see the percentage, right? Percentage of mass of FeSO4 7H2O, right? So you'll be getting what is that? Formula can we use? That is given mass by total mass of the sample. Total mass of the sample. Okay, so total mass of the sample 32 gram. Now in the question, first point that 32 gram, right? So here 22.24, right? So 22.24 gram divided by 32 gram. So finally you are receiving the value percentage into 100. I just forgot here 100 percentage means 100 here percentage, no, 100. So here also 100 into 100. So please remember that point. Okay, now see here, when you calculate this 22.4 divided by 32 into 100, so you'll be getting what it is, 69.5 percentage. I hope you are receiving. Now whose value is this? Percentage of FeSO4.7H2O, right? I hope you got that idea how to solve this question, and already many questions like this type we have solved, right? Previous video and before that video also we have gone through percentage purity, how to identify the percentage purity, we have gone through. Just go through once again if you have doubt. Yes. So which is the correct option? Option B is the correct option, 69.5. I hope you got a clear idea about all these questions. Yeah. The next question we can go through in our next video. And thank you for watching.